To all critical thinkers and problem solvers out there, this is Mr. Schaefer with another friendly greeting as we dive into the world of quadratics and equation solving. What do we do to equations in mathematics? We solve them. But what do we do if there's a variable that is being squared, like x squared equals 49, or x squared equals 0, or x squared equals negative 64? So we have this method that we call the square root method, and it allows us to wipe out or undo that operation of squaring a variable. We simply take the square root of both sides. Don't forget, what you do onto one side in algebra, you do onto the other side to maintain equality. So when you're finished with that, you end up with x equals the square root of the right-hand side, which is 49 in my first example. But remember that there actually can be two solutions. So when we take the square root of both sides and we square root a variable squared, we need a plus or minus on the answer. It is possible that if x squared is equal to 0, we could have one solution. There's no such thing as a positive or negative 0. So here we just say x equals 0, and we have one answer only. X squared equals negative 64. Well, there is no number that you can square to get a negative, at least in the real number system, so there is no solution for that type of equation. Or to be more specific, we'd say there's no real solution to that equation. So I'd like to take you through a series of examples in which we solve equations by the square root method. The first step here is to isolate x squared, and then the second step is to square root both sides. And remember to use that plus or minus on our answer at the end when we're finished. So number 1 says 2x squared equals 8. I'm going to divide by 2 because I want to isolate the x squared. So x squared here is equal to 4. And then square root the left and the right, and we'll find a solution of x equals 2, but don't forget it's plus or minus 2, because when I square 2, I get 4. When I square negative 2, I also get 4. Two solutions, plus or minus 2. In the next example, I'd like to get both an exact and a rounded answer. So I'm going to use my calculator for this one here. And we're going to round, it says, to 2 decimal places. So notice that in the directions. Problem number 2. Solve 2x squared minus 18 equals 22. Let's first add 18 across to both sides, which would be 40 on the right-hand side. Divide both sides by 2 to get x squared by itself, and I have x squared equals 20. Now when we're finished, or before we're finished, I should say, let's check this radical here. Take the square root of both sides, and we'll get x equals plus or minus the square root of 20. The operation of taking the square root will cancel out that power of 2. Remember, too, from simplifying radicals that the square root of 20 can be split up into root 4 and root 5. I'm searching for the largest perfect square in that number of 20, the largest perfect square factor. And 4, or root 4, becomes regular 2. So plus or minus regular 2 times the square root of 5 is my exact solution for x. And again, it's two answers, positive 2 root 5 and negative 2 root 5. So how do we find the rounded answers? Well, for those, we're going to go into the calculator, and I'm going to simply type in on the home screen 2 times the square root of 5, and I'll press enter. My answer here is 4.472. I'll round that to 4.47. And then negative 2 times the square root of 5 will be the same number, but just negative. So negative 4.47. So the exact answer and the rounded answer. I'm going to skip number 3 and look down here at 4. Notice in front of the x squared, I have a fraction of 1/3. First, let's add 8. 1/3 x squared is equal to 15. To get rid of a fraction in an algebraic equation, we want to multiply by its reciprocal, or in this case, I'll multiply both sides by the denominator of 3. So left and right side by 3. That'll cancel out the 3, and I'll have x squared equals 3 times 15, which is 45. Again, I'm ready here to take the square root of both sides. Regular x, because the root and the power of 2 cancel out, regular x is equal to plus or minus the square root of 45. Now that can be broken down because there's a 9, a factor of 9 within the number 45. Square root of 9 is 3, so I have plus or minus 3 times the square root of 5. There's my exact answer. The rounded answer, again, I'm going to type that in the calculator to find out what 3 times radical 5 is equal to. And my answer is 6.708, or I'll round that to 6.7. Let's call that 6.71. And it's plus or minus, rounded to 2 decimal places. Number 5, I'll do that one by myself. See if you can follow along with the steps that I'm doing here. X squared terms on the left. Isolate the x squared, square root both sides, and don't forget your plus or minus at the end. Here's where they get a little bit tricky. Take a look with me at a couple more examples here, solving by the square root method, but here we're going to see that there's a binomial quantity that's being squared, not a simple x, not a lone variable, but a binomial that's being squared. Here's a good reminder of the steps. We want to isolate the binomial squared first. We'll square root both sides. Don't forget plus or minus. But after that's finished, we then have to continue isolating the variable to find our solutions at the end. I'll start with the basic one here in number 7. X plus 3 quantity squared is equal to 12. To get rid of that power of 2, I'm going to square root the left and the right-hand side, because that root will wipe out the power of 2, leaving me with an x plus 3, a regular x plus 3 on the left-hand side all by itself. On the right, I still have that plus or minus and the root 12. To get x by itself, subtract 3 from the left and the right. So x is equal to -3 plus or minus the square root of 12. Now, radical 12 can be simplified into 4 times 3 under the radical, and radical 4 is simply a 2. So I have -3 plus or minus a regular 2 times the square root of 3. In fact, that would be the exact answer right there. For the rounded answer, here's what we're going to do. I'll come down here and write my rounded answer. -3 plus 2 radical 3 will be my first rounded answer, and then -3 minus 2 radical 3 will help me find the second rounded answer. Type both of these expressions into the calculator. I'll put calculator right there to find out what the rounded solutions will be. So -3 plus 2 radical 3. Press enter. I have a value here of 0.464. Let's check rounding up here. It says round to 2 decimal places once again, so we'll go ahead and do that. 0.46 is my first solution. And then -3 minus 2 times the square root of 3 is -6.464. So again, we'll round that just to 2 decimal places and call it -6.46. Now, I'd like to end with one more example, just kind of putting all of these different pieces together to see how this comes about. So why don't we begin, well, why don't we end, I should say, with, let's end with number 11. So number 11, subtract 5 from both sides. And we'll have x plus 4, quantity squared, equal to 36. There's a perfect square. That's going to be kind of nice. I'll take the square root of both sides, square root and square root. So I have regular x plus 4 because the root and the power of 2 cancel out, equals plus or minus the square root of 36, which is just the number 6. And then subtract 4 to get x by itself. Now what that means is I really have two answers there. There's two numbers. And I'll draw a little split like this with two arrows to show you the two numbers. Negative 4 plus 6 is my first answer, or 2. And then negative 4 minus 6 would be my second answer, which is negative 10. And I'll write those down here as my exact answers, 2 and negative 10. So that's how we use the square root method to solve quadratic equations. We use square roots to isolate variables or binomial expressions that are being squared. Don't forget that plus or minus when you take the square root of both sides. Thanks for watching.